Hi folks, in this next video in our series of videos really about differential equations, we're going to be having a look at a pretty classic kind of differential equation that's used in lots of different applications, and it's one that I've mentioned in OneNote here under this title Applications of Differential Equations. And it's this kind of situation where you've got a quantity which is changing, so we can describe it by a rate of change, and the rate at which that quantity changes depends on the amount of that quantity. And that sounds like a real mouthful and it sounds a little confusing, but let's just take a simple example. Let's say you're investing some money. You're lucky enough to have some money to invest, so you invest it. And I think this would be common sense, logical idea that the rate at which the amount of money that you have changes, so let's call M the amount of money, and I'm looking at this line here. So the rate at which the amount of money is changing with time depends on the amount of money. So this is like a proportionality statement that you can make into an equation using a constant here. So the rate at which the amount of money is changing depends then on the amount of money. And that makes sense, I think, because the more that you have of this of money, then the greater would be the rate of change. Now, if you if you think about that, the more you have, the more quickly you will increase the amount of money, especially if it's something like compound interest. So if I was to graph that for a second, okay, then let me just quickly draw on the screen here just to show you what a typical kind of graph for this kind of situation would look like. Well, if this is the amount of money here, and sorry, not the amount of money, that should be time, of course. So let's get that redrawn. So if this was time and this is the amount of money, let's say you started off here with this amount, I don't care what it is, whatever it is, then what would happen is that your amount of money would slowly increase, but would increase like that. This is called exponential growth. And this happens with compound interest. Now, if you start off with more money, then that increase will happen still slowly at the start, but more quickly. So the more that you have, the more quickly you will see this exponential growth start to occur. Okay, and so what we're going to have a look at in this video is how do we solve a differential equation of this type here. Okay, so let's move to that and we'll have a look at that. So I'm just going to clean up my screen here and we'll just pop over to the video in a moment. Okay, so let's do that now. Right, so differential equations of this type here. Now, rather than calling it M for money, I'll just have a general quantity y, which is and the rate at which y is changing depends on the amount of whatever this y variable is. Okay, so let's have a look at solving this. In the second video, there are a number of examples that I've shown of how to use this in various type of questions. So what we're going to do, a bit like the separating of variables idea, we're going to put the dx over with the constant, and we're going to put the y variable over here with the dy. So we get there, and now to solve this we're going to integrate both sides. Now this should be the natural log absolute value of y equal to k t, where in fact why have I got x there? Some of you should have stopped me there and said, hey, what's going on there? Of course you couldn't do that, could you? So make that dt and make that dt, and this will be kt plus some constant. And like we looked at with the separating of variables idea, I'm going to replace c with natural log of k. Okay, so at this stage here, in fact, no, I'm not going to do that at this stage at all. What I am going to do is take the exponential of both sides. So if we take the exponential of both sides, this side will become y, and this side over here will be e to the power of kt plus c. Now what I am going to do at this stage is I'm going to remind you of one of the basic ideas of indices, is that if you have a to the power of m times a to the power of n, that would be equivalent to a to the power of m plus n, and so that's true in both directions. So what I'm going to do is I'm going to use that, and I'm going to write this as two separate exponentials. Now at this stage this here is simply a constant, e to the power of c. Okay, it's simply a constant, and we can call that constant anything we like, and I'm going to call it E0, a little subscript there, 0. So we can say y equals y subscript 0 e to the power of kt. Sometimes you might see other texts call it a, that constant sometimes called a, so an alternative that you see quite often is a e to the power of kt. And there is our solution, either of these two. Okay, so what we would need to do if we were working with a question typically, we would need to find out what that constant's equal to, and we'll need to find out what that constant there is also equal to. Okay, so a and k are constants. And that's it for this video, and in the next one we'll look at how to apply this. But what we're going to now assume is that since we know how to solve this kind of differential equation, we're not going to put all these steps in each time. We're simply going to say if we've got something of this type here, well, the solution would be y equals some constant, either y0 or a, e to the power of that constant there, and that variable there, in this case t, would be the power of that exponential there. Alright folks, we'll catch you around and in class. Have a good one.